Section 11.4 is going to actually start our talk about circles. We haven't actually really spent a whole lot of time with circles. And the nice thing is it actually starts with some vocabulary that we should already be comfortable with, and we actually did spend some time with. This was way back in Chapter 1. But you've seen this even prior to the school year. Notice the title is dealing with, we're dealing with circumference and arc length. Now, arc length is kind of the new piece, okay? So we're going to get into that, and then actually we're going to spend a little bit more time on this another day, okay? So let's start with what we already know. We know circumference is basically the distance around a circle. So another way of saying that, it's just like the perimeter of a circle, okay? Now, the reason why you don't use perimeter instead of circumference is because perimeter is usually attached to a polygon. So
when we add the side length, there's no side length.
Exactly. So we need to know an actual formula to find the circumference. So can you refresh our memory, Ms. Hoke-Gravy?
Well, I remember there were two formulas that deal with pi.
Okay.
One was pi r squared and one was 2 pi r.
Okay.
And the circumference should be the 2 pi r.
Okay.
And in case you guys forget that, I always think, okay, they both have a 2, a pi, and an r. The r squared goes with area because that's when we have unit squared, so this is just our 2 pi r. Or another way of saying that would be, since I've got 2 radius, the diameter times pi.
Now, I like how you said that because it does make a difference, guys. If you use pi r squared versus 2 pi r, you're going to get more than likely different answers.
Yeah.
And that's probably one of the most common mistakes. And, and guys, when we get to section 11.5, which is coming up, we're going to be talking about area of a circle. So we do have to know the difference between the two. Now, just a reminder, radius goes from the center of a circle to a point on the circle. Kind of like the radius of a regular polygon, right? But this time, because it doesn't go to a vertex, because there's no vertices. And the diameter basically are 2 radii made up. So if I draw all the way through the center from one point to another, this whole thing is the diameter. Okay, so again, just a good recap of what we're doing there. All right, so we're going to start with kind of a basic example, I believe. So we want you to try this one on your own, okay, and then check with us.
All right, we're supposed to find the radius of a circle, and they give us the circumference in terms of pi. And you're going to start to see a lot of things left in terms of pi, so don't let that freak you out. So we know the circumference already is equal to, and we could say either pi diameter or pi r or 2 pi r. And I'll tell you that since they're looking for the radius, let's go with our 2 pi r. And they give us the circumference is what?
52 pi. And don't leave off that pi. And don't also go ahead and take 52 times pi in your calculator.
Yeah, just leave it, and you'll see why you're going to leave it here in just a second. All right, now, we want to try to find just the radius. Okay. So what am I going to have to do to get this r, the radius, by itself?
Well, we're going to have to divide by 2 and pi.
And we can do that at the same time. 2's and pi's cancel here. What happens with these pi's?
A pi divided by pi is just 1, so that cancels out.
So I'm really just taking 52 divided by 2.
So r ends up being 26, and this is in inches.
Love it. The radius is a linear unit.
Yes.
All right, linear measure because it is just a distance from the center to any point on the circle.
Now, guys, notice again, you're not using the pi at all, or like typing it in your calculator. So that's one thing. That's not, the one reason why we a lot of times leave things in terms of pi is because it's a lot quicker. Conversation that we might end up having eventually is, how do I type that in a calculator? Okay, there's a pi button, and then there's what pi is about, which is 3.14. What do you think we would prefer?
Well, you know we love exact answers here. So we're going to say always use your pi button. And the only reason you would not want to use your pi button is if you're taking the EOC and they say use 3.14 for pi. Because any test we make up, anything that we will give you, we will want, even on a worksheet if it says use 3.14 for pi, we want you to use the pi button.
Yes.
Okay? Good discussion.
All right, so before we get to what an arc length is, because that's the other part of this, notice circumference, that was quick. Arc length involves some vocabulary that we're going to kind of hit on first. And this is actually some vocabulary that chapter 10 discusses. So we're going to see this again in chapter 10, but because we did a little flip-flop, we have to kind of interject this in chapter 11. Okay, so bear with us. We're going to go through some vocabulary that all leads into this idea of an arc. Okay, now the first term, we've seen this before. We just recently discussed area of a regular polygon. We talked about a central angle, right? A central angle in a circle has some similarities, but there are differences because it's obviously not a polygon. It is still an angle, and the vertex is at the center of the circle. Hence the idea of a central angle. Okay.
Yeah. Now, I remember when we talked about polygons, we went, for a central angle, we went with 2 consecutive radii. Well, here, I could do a radius anywhere I wanted to.
Exactly, because there's no vertices for you to draw the radii. So as long as you have the vertex is at the center, and I'm going to make a little note, it's basically formed by 2 radii. And it doesn't matter which 2 radii you use, all right? It's just as long as you have 2 radii. Now,
and you can't really talk about consecutive radii with a circle, so...
And most of the time when you're talking about a central angle, it is going to be an angle that is 180 degrees or less. Okay, we'll talk about what happens when it's larger. All right, now notice it says the measure of a central angle is the measure of its intercepted arc. Now, this is a new word, arc, all right? So in this picture, the angle we're talking about is angle A or BAC. That's your central angle, okay? So this right here is our central angle. So they're saying that measure is equal to its intercepted arc. Now, what I'm talking about an arc, all right, is basically a part of a circle, okay?
It goes from one what? From
one point on a circle to another point on the circle. Now, notice the intercepted arc we're talking about is actually, because we could have an arc in here, but it is the points that make up that arc actually intersect with that central angle, okay? So this is the intercepted arc here. How we name an arc, we could say just, and I'm going to make a little note here, arc BC, and notice we're using the endpoints of the arc, okay? Another way of saying it is saying arc BC with the little arc symbol above it. Okay, so the measure of angle BAC is the same thing as the measure of arc BC, if I can write it correctly. Arc BC. Okay, so, and if you think about, and you're talking about a protractor, when you measure an angle, you're kind of measuring along, you're looking at the degrees. So the degrees of this is the same as the degrees of that. Okay, when you're talking about measure, you're talking about the degrees. All right, we'll talk about what I mean, why we said that in just a minute, okay?
All right, so some more vocabulary. We have different types of arcs. We have minor arcs, we have major arcs, and a semicircle is a very specific arc that you would see too. So when you talk about a minor arc, it sounds small, and that's because it is. It's the part of the circle that would measure less than 180 degrees. So it is less than a straight line, okay? It's a smaller angle. They're named by their endpoints, just like we showed arc BC on that last example. I could go ahead and write arc BC like that as well. Okay. The measure is the same as the measure of its central angle. This is exactly what we just talked about on this last slide. Okay. Again, this is degrees. Now, when we talk about a major arc, that sounds bigger, and that's because it is. Okay. So it's the part of the circle that measures between 180 and 360 degrees. So it's the kind of the what's left if I took out a minor arc. Okay, so it's the larger part. Again, it's named by their endpoints, but also by a point on the arc. So if I draw a picture here,
we could even go back to the last one.
Sure, let's just go back to the last one since we already had the picture. We know that arc BC is a minor arc. What would be a major arc on this one?
Well, something more than 180 but less than 360, because 360 would be the whole circle. So, and you said name it with its 2 endpoints and a point that's on the arc. So what about arc BDC?
Yeah. that whole rest of the circle. And I love how you put the D in the middle because that's the point that's on it. So you kind of like when we're naming an angle, we always put the vertex in the middle. Here we're going to always put the point that's on the arc in the middle. So arc BDC. And when we're naming that, we do use all three of those, BDC, with our arc. So just by looking at the name of an arc, we'll know if it's major or minor. Because we'll know if it's minor, it'll only have 2 letters, and if it's major arc, you'll see 3. Okay. The measure is going to be the difference between 360 and the measure of the associated minor arc. Now, the reason we say that is it's basically, instead of the smaller angle, it's what's left.
Yeah. So like on that last picture, real quick. So if arc BC was, let's say, 60 degrees. Then what's left would be 300 because that's 360 minus the 60.
Exactly. Okay. Now, semicircle, hopefully we know that word. We've seen that before. It's just going to be exactly 180 degrees. It's half of the circle. It is considered a major arc because it's between 180, or it's named, I should say, similar to a major arc because it's kind of in that 180 degree realm. The reason with a semicircle that we have to name it with its with the 3 letters is because if I say this is maybe an A and a B, and I'll say this is point C, I want to know that if I say arc ACB, I'm talking about that side of the circle, as opposed to if I said ADB would be this side. So it's just a way to kind of keep track about where you're talking about on the circle.
So just to, again, clarify, okay, semicircles and major arcs, those are the ones that they're named the same. Now, they're 2 different arcs.
They are different.
Yeah, major arc has to be greater than 180. Semicircle is exactly 180. But I like how Ms. Huckerby said, you have to name it with 3 letters because otherwise, how do you know which semicircle we're talking about? Yes, they measure the same amount, but you have to be specific, okay? So, again, how you look at a name does matter. Would you ever name a minor arc with 3 letters?
Never.
Yes. So it's if you see 3 letters, it's either major or semi-circle, or minor is always 2 letters.
And even if there was another letter between there, I would still just call that arc CB.
Yeah.
Okay. Awesome. There's some vocabulary for you. A little bit more vocabulary.
Okay. Now, here's where we're going, okay? All this deals with arc length. That's going to be that title. We know what an arc is. Arc, again, is part of a circle, all right? The length of it is different than the measure. I want to stress that, all right? Again, it's the measure is talking about degrees. Arc length is talking about basically how long. Here's what I think about. If you were talking about arc AB, so this arc right here, part of a circle, and if I like cut along the arc or the circle right here and I kind of flatten it out, what are you going to see?
It's going to be just a linear unit.
Okay, a segment, right? So to measure a segment, we measure in like units of centimeters or inches or feet or whatever.
Right.
Arc length is when you're finding the arc length, you can measure, okay, you're going to find the length in linear units. The length is in linear units where the measure is in degree amounts. Very easy to mix up because when you think of measure, all right, you can
sometimes we've used it for
But when you're talking about arc length, there's 2 ways to actually talk about it's either in degrees or in linear units. So when I talk about linear units, again, that's like centimeters, feet, things like that. Okay. So again, arc length, when you're talking about the length of it, you're going to be talking about linear units, all right? And there's a way to find this, okay?
And notice it's just a portion of the circumference of a circle.
So I want to stress that, okay? The next slide is going to tell you how to find the length of this. And I like how you said this again. It's the portion of the circumference. So if I know how much the circumference is, basically how big that circle really is, because the circumference that's how it's going to communicate that. And basically what part of that circumference it is, then you know how the length of it, okay?
This sounds like we've got a part to whole relationship.
Yes.
Like maybe a ratio is coming into play. And there is a corollary theorem to talking about just arc length, okay? So it's very specific about a circle because it's just about the length of the arc. And it says, in a circle, the ratio of the length of a given arc to the circumference, because we know that arc length is just a portion of that circumference.
Okay.
So I'm going to write that. The length.
So the arc length.
So I'm just going to go ahead and talk about arc AB here.
Okay.
So the length of arc AB compared to the circumference of circle P.
Can you put
circumference?
Can you put an arc measure or arc?
Oh gosh, yes, that's what I meant to put, and I just
Yes.
didn't. Okay, all right. Is going to be equal to the ratio of the measure of the arc. Now, measure again was talking about degrees of the arc. So I'm going to say the measure of arc AB, and again, that's degrees. And we're taking it out of 360 because if you're, again, talking about the part to whole, the whole circle has 360 degrees when I put all those central angles together. So we have this lovely part to whole relationship going on.
Okay.
The length of the arc, the distance from just point A to B along that circle, along the outside of that circle, compared to the whole circle, is going to be equal to the same part to whole relationship, but when we talk about the degrees of that central angle compared to the entire circle.
And again, notice, guys, again, that part to whole. You're keeping the linear units kind of together and then the degree units together.
Exactly.
Okay? Again, that part to whole idea.
All right.
So now let's try some examples. Now, here's the deal, guys. When it says find the length, we're not finding degrees. This is dealing with actual units like centimeters, feet, inches, whatever. Okay? If they say find the length, that's not going to go ahead and say, well, it's 60 degrees. Okay, length is not measured in degrees. So keep that in mind. That doesn't make any sense. All right?
And if they said find the length, we wouldn't just give
Give
the
it
length
to you.
here.
Exactly. All right, so here's what I want you to keep in mind. All right, again, if we kind of go back a slide here, the length of an arc compared to the whole circumference of that circle is equal to the degree, the measure of that arc to the whole 360, okay? So what is it that we're trying to find again?
The length of
the
the
length
arc.
of the arc. So we're finding the length of this arc, how long it is, all right?
Okay.
So I'm going to make just a note, and we'll kind of fill some things in just a minute. The length of arc, JK, to the whole circumference. Now, how do you find the circumference?
Well, we can find the circumference right now because we know circumference is 2 pi r.
And so you do 2 pi times what is the radius?
And we have a radius of 16.
Okay, equals, and it's going to be the degree amount measure of arc JK. What would that be?
The 60 degrees because it's the same as its central angle measure.
Good. Always compared to
360.
because it's always 360 degrees all the way around, okay? So let's put, instead of saying the length of arc JK, let's put an unknown. Let's just say X, okay? And then let's go ahead and simplify this down. That is
32 pi.
Now, something that you can do, but you don't have to. I often simplify this fraction over here, but again, you don't have to because you can still work with it. It's just a proportion.
Yeah.
All right.
So that just gives
this
you
is
1/6.
1/6. The reason why I do that is because this
Makes it a
basically
little bit
a little
easier.
easier to work with. If you don't do that, no biggie. Okay, no biggie at all. All right. So now we can just cross multiply, right? So
Right.
and guys, I'm not going to type in 32 pi in my calculator. I'm going to leave everything exact, and then we'll talk about if we're going to round or not. So we're going to do 6 times x, and then equals 32 pi. Notice I didn't even have to touch the calculator.
Right.
And then I'm going to divide each side by 6, right?
Yeah, and
So we're gonna
32 doesn't divide very evenly, but you get like 5 1/3.
Okay, but we could simplify this.
Right.
All right. So what number goes into 32 and 6?
Let's see. 2.
2. 2 goes into 32 16 times. 2 goes into 6 3 times.
So you could leave it as 16 pi over 3, or you could say 5 1/3 pi.
Now, I personally,
You like the 16 pi over 3.
and the only reason is because the 5 1/3 pi, okay, yes, that's exact, but this is a lot easier to kind of work with when we start applying it to
So
other
true.
things.
So true.
All right. So leaving it as an improper fraction would be more realistic for if we ever apply it somewhere else. Okay. So this would be an exact answer.
Okay.
Now,
when I type it in my calculator with the pi button, because we know that we're talking about units here. We're talking
They
about
do have
inches.
units. So if they give you units, then we probably want to round, okay? So we usually round to maybe 2 decimal places. So if I type in 16 pi, actually the pi button, and then divide by 3, you're getting approximately
16.76. Which, if you think about it, you're taking 16 times pi, which is a little bit more than 3, and then dividing it by 3. Makes sense that it's just a little bit more than 16.
Yeah. So again, the question that I often get is, when do I round, when do I not? We've talked about this. If there's units, guys, make sure you are rounding. If there's no units,
leave it exact.
And they don't tell you to round, then you need to leave it exact. And exact would be in terms of pi. This really means I don't really have to touch my calculator.
Yeah, which is nice.
Which is obviously nice, okay? So we've answered the question. We're good.
We're good. All right, next one. Now we're finding the measure of arc LN. So the last one we found the length of an arc. Now we're finding the measure of the arc. And when we say measure, we know we're talking about what?
Degrees.
Degrees. So we don't know the degrees yet.
Okay.
This is what I'm finding. So I'm going to go ahead and say, let's just call it X for right now. X degrees. So X over, and we know degrees is always out of
360.
360. There's our part to whole. Now, do we know the length of the arc yet?
Yes, it's the 16.76 inches. And notice again inches, so rounding was probably what we're going to do.
Do we know the whole circle circumference?
No, but we can find it. So it's going to be 2 pi r, so we could be 2 times pi times 8.
So 16 pi.
Now, could I just put that in, like, just do 2 pi 8 up there and then just simplify down?
Sure.
Okay.
Yeah.
And so she's showing another way, and I was going to suggest that, and I forgot on the last slide. So you could put it off to the side. I often have students that will do it directly in the proportion and then simplify down.
Yeah, either way. All right, and when you cross multiply, you're going to get 16 pi x is equal to, and then we know we're going to take our 360 times our 16.76 to get,
which is 6,033.
Oh, 6,033. Got it.
0.6.
Love it. And then we know we're going to end up doing what?
Divide by 16 and pi.
Now, I know on this one, we will commonly see some mistakes made.
Yes.
And I'll have people that type this in their calculator and say, I typed it in my calculator, how come I got a different answer? And here's why. Because if you notice that when you type this in your calculator, if you just take 6,033.6 and divide by 16 times pi.
This is what you're going to get. You're going to get 1,184.7.
Okay. Now,
that doesn't make any sense.
It doesn't make any sense because you know you're dividing, first of all, the 6,000 by 16. Here you've only really divided by like maybe a little, like 6-ish.
Well, and the reason why it doesn't make any sense is because you're finding the measure of an arc, and you're finding
can't have a degree.
You can't have it more than 360.
So please use parentheses. Whenever you divide by more than one piece, always use parentheses around that denominator. And what should you approximately
get? When I do that, you get around 120 degrees.
Which seems way more logical.
Now, guys, the other thing you could do, you could divide in 2 steps. You could divide that 6,000 by your 16, and then you could divide that by pi. So you could do it in 2 steps. And again, be realistic. If you put an answer that's 1,000 for a degree measure of an arc, okay, the whole circle is not even close to that. So it's part of 360. So measure should always be less than 360. Okay? All right. This question says, find the circumference. Right now, I want you guys, we've done 2 together. Each of them have been a little bit different. We found the arc length. We found the measure of an arc. Now we're finding the circumference. I want you guys
all of them, you're just missing a piece of that ratio, or piece of that proportion.
So go ahead and try to find this on your own. Pause it. Check it with us when you're not.
Okay, so on this one, we've got both the measure of the arc and the length of the arc.
Okay.
So we have both of our parts. We just don't have both of the holes, but we know the whole of the degrees is always 360.
So if what I'm finding, again, is that circumference. So if you think about it, if I set proportion, what goes along with the circumference.
The arc length.
The arc length, which is what in this case?
The 10.2.
So I'm going to say 10.2, and again, notice it's in centimeters, so we'll end up rounding here, divided by the circumference.
Now we could use either just C for circumference, or we could use our 2 pi r.
What would be more realistic in this case?
Well, I'm trying to think here. We're just trying to find the circumference, so I'm just going to leave it as C.
Yeah.
Because we don't need to get to the radius or anything else.
Now,
but I know that there are some questions on your homework where you might be finding a radius. So depending, you could still even put the C in for those two. But if they ask for like a different measure, like a diameter or a radius, you could put that formula in there too.
Since they're asking you to find the circumference, let's just say that's what we're finding.
Sounds great.
Equals my, getting the part to whole, so it's my degree, a measure of that arc, which would be
45
over the total 360. Now, you could do what we suggested on the last one and simplify this ratio. Again, guys, you don't have to simplify this ratio. You could just go ahead and cross multiply and divide and be done. All right? Are you simplifying it?
Yes.
Why don't we do that just to see what it would look like? You don't have to.
It would give you 1/8.
And notice that, again,
makes it nice because then it's just C.
So it's going to be C times 1, which is C. So all you're doing is multiplying the 10.2 times 8, which is
81.6.
And we don't even have to round there. And this is in centimeters. Now, something to keep in mind logically, the length of an arc has to be less than the whole circumference.
Yes.
Keep that in mind. The measure of the arc has to be less than 360. All, again, logical things to think about, okay? Another thing before we end this is when you do find this simplified ratio here of 1/8, okay, think about this is saying it's 1/8 of the whole circumference, okay? So you could even check, does 1/8 of this actually get you to 10.2? And it does.